Okay, we're recording. Yeah. So happy National Brandied Fruit Day. A lot of birthdays today. Snoop Dogg, Kamala Harris, Tom Petty, Mickey Mantle. This 1931 was born. And the random fact of the day, brought to you by another student. Farts travel at 10 feet per second. Random fact of the day. Okay. She wanted to start that segment after she saw the other stuff. In the top, we have an odd number, we have an odd number, and we have an odd number, right, to the first power. And so what's going to happen with all three of those terms when we plug in a negative z? Are they going to change or stay? They're going to switch. They're going to change. All three of them will. And if all three of them will, that means that the top function is an odd function. In the bottom function, we have an odd and an odd. So the denominator will then have two terms, both of which change signs. That means that the bottom is also an odd function. And what is an odd divided by an odd? Well, remember, odds act like negatives. So what's a negative over a negative? Positive. And a positive is analogous not to an odd, but to an even. Yeah. Oops. Don't you hate it when you have the wrong eraser? The answer is yes. Even. It's kind of hard to write with these motorcycle gloves on, but you know what? Safety first. The gloves protect your palms when you inevitably fall off the motorcycle and catch yourself like this. Ouch. Did you hear what I said? Inevitably. Even the safe drivers fall off eventually, especially if they just run out of gas. That would suck, running out of gas on a motorcycle, like right in the middle of nowhere, and you just like all of a sudden tip over. Dunk. Drag it back? Oh, well, they got to drag those wheels. They're a lot heavier when the gas tank is empty. Yeah, yeah. All right. A, B, C, D, E, F, G comes next. G comes next. Okay. What do we have in the top here? We have three terms. We have an odd, and we have a constant, which is even. Whenever you have a combination of some changing and some not changing, guess what it is? It's neither. And it doesn't really matter what the bottom is, does it? It's neither. Yeah. The bottom, by the way, is what? Just for kicks and giggles. This one is an even exponent. A constant is also an even function. It has y-axis symmetry. So an even and an even, that's an even. Neither one of them will change. Yeah. Neither one will change. So a neither divided by an even is a neither. All right. The next one, we get f of negative x is equal to negative 3 times the cube root of 8 times negative x. Okay, well, here's the deal. Off to the side. Well, we can because it's a what? There's a variable and it's a cube root, so negatives are okay. Yeah. If it were an even root, it'd be game over. Even roots don't have y-axis symmetry at all, but odds can, or they can have origin symmetry. So in this one, here's a little fact off to the side. The cube root of negative 1 is negative 1. So if I take that cube root of negative x out of there and call it negative 1, what's that negative going to do with the 3 up front? It's going to change its sign. It looks like that. If you really want to see that in slow motion, here's what it looks like in slow motion. Negative 3 times the cube root of negative 8x, which is equal to negative 3 times the cube root of the cube root of negative 1 times the cube root of 8x, which is now equal to negative 3 times negative 1 times the cube root of 8x, which now means that this is 3 times the cube root of 8x. And that changed the sign. This is the opposite of f of x. The opposite of f of x. Therefore, what? So F is odd. Yeah, it has origin symmetry. Now, you don't have to really show all those steps. You could just say right away from the beginning that this equals this right here. This equals that. I hope you could do that, but if not, you can show this. That's fine. That's fine. Okay, the next one. We get TD, touchdown, we're going to score. Let's do this first before we replace D with negative D. Let's rewrite the top as the cube root of D squared. All over the square root of D squared plus 4. Now, when you write it like that, look how it makes it easier to talk about the numerator and denominator. Is the top even, odd, or neither? It has an odd exponent of a third, but look what the first thing we're doing to it is. We're squaring it, right? So plugging in positives and plugging in negatives, is it going to change at all in the top? Is it going to be the same? Yeah. And when that happens, that means that it's an even function. And in the bottom, D squared plus 4, square root of it, what's D squared plus 4? That's going to give you an even function, right? Because D is squared. So you get an even over an even. And what's an even over an even? What's a positive divided by a positive? Positive. So an even divided by an even is even. Yeah. So in this case, it's easier to write it in radical format to do the analysis rather than taking a radical and writing it in fractional exponent format. Okay, so let's summarize here. If none or all of the signs change on a single line, then if none of the signs change, sorry, none. We'll do that first. If none of the signs change, then the function is what? Even, yeah, even. And if all the signs change, then the function is odd, yeah. And if some change and some don't, then it's neither, yeah. All right, now for quotients, right? An even divided by an even is an even. An odd divided by an even or an even divided by an odd is an odd. An odd over an odd is even. Yes, even. And then a neither over whatever or whatever over neither is neither. Yeah. Let's put an N for neither. All right, putting it all together now. Putting it all together. For each of the following, find the domain, end behaviors, symmetry, everything that we've learned about the graph. Okay. Step 1, let's find the domain. That's the first thing you should think about when you have a function like this. Find the domain. Well, to do that, since I have a denominator that is a polynomial, I'm going to want to factor it, right? And if I'm going to factor it, I might as well factor the denominator as well. So that would be how you find the domain. So working straight down, let's just say that f of x equals, and we'll draw our horizontal division line. We'll pull out the 2 first, and we get x squared minus x minus 2. Because what's the first rule of factoring? Take stuff out. Look for the common factor, yeah. And in the bottom, we could do the same thing, right? Factor out a 3, and that gives us x squared plus 3x minus 10. That's the first step in factoring. Now, I can try to factor what's left as the product of 2 binomials. So I'm giving myself the template right there. Okay, here we go. Now I'm focusing on the task. It's x squared minus x minus 2. So it's got to be an x, and it's got to be a minus 2, and it's got to be a plus 1, right? To get your sum to be a negative 1 and your product to be a negative 2. All right, and in the bottom we got an x and an x, but now we're looking for factors of negative 10 that add up to 3. It's going to be positive 5 and negative 2. And again, those factors can be flipped, right? We typically write the 2 and 3 in front, but the x minus 2, x plus 1, those can be interchanged, same as the bottom, okay? All right, so now look. I'm looking in the bottom and I see x plus 5 and I see x minus 2. Right away, I can tell which two values of x are not in the domain. I'm just going to tell myself. I'm going to write this here because this is what I'm telling myself. X can equal negative 5 and x cannot equal positive 2, right? Those are the whats of those two factors. Those two numbers are the whats of those two factors. Rhymes with boots, starts with R. Roots, yeah, roots. I say roots, and my family is like, it's roots. And I'm like, not where I come from. Where do you come from? They say. I say, from my roots. And then it starts all over again. You're not supposed to say roots. Roots. You say roots. Well, not where I come from. Where do you come from? So here's what we do. Breathe. Move. We're going to have ourselves a vertical asymptote. You say x equals 5 and what's left of it is the 2. All over 3 times 5. You might want to warn people and tell people or people confused and it's no longer. Alright, so now we actually get to plug in the 2. Well, let's go ahead and do this. It's just a constant, right? Originally two values that made the numerator zero. information. So here's where we go ahead and make the flower. Right. So this horizontal axis. Here's what's in that we allow to just one zero. And so far I've collected all the right? Oh, that was a good idea. Really, really what we're doing. there. If they happen to live below this to be above. So when you're drawing this part here, you can answer questions like drawing and we can that's a good place to start. And then what about, hey, what comma 2/7? Still increasing, right? It's monotonic increase over poisoning. if we had time. Like it. Well, that's the domain. Find the domain. Three of those. Let's look at the horizontal side. Find it, but if the numerator is factored, into infinity this way. Fast is the graph changing. Y'all might be interested. What's going on next 9 weeks? Okay. Comments or questions?